not really sure about it. Where exactly are we online? Is it Twitch? Okay, it is Twitch, indeed. All right. So I'm not really sure if you can hear me. Obviously, no one is there. Okay. So the plan today, I thought, to brush up on GraphQL. So I have not used GraphQL that much, and I think it would play out well with the last video I made on my YouTube channel about not following tutorials. And well, this is not going to be a tutorial, right? Because I'm as beginner as you if you're trying to, learn GraphQL. Otherwise, if you are a master, then I don't know what the hell you are doing. I mean, why did you open this video? Anyways, let's go to GraphQL documentation and start off there. Okay, introduction to GraphQL. So if you don't know GraphQL, so what exactly GraphQL is I guess you can think of it as a design pattern for APIs, right? So kind of let's say you have REST APIs, right? So what REST APIs do is basically they will so you create routes for every resource, right? I was not getting the word for that. Anyways, so in REST APIs you create a route for every resource, right? In GraphQL it's not the case. There's only one endpoint, and with that endpoint we can pass in the request only. We can pass what all we have. We need the response, I mean in the response, like and they can be nested as well. So that's pretty cool. So you only need one endpoint, and well, it will give you the response for everything, right? And it seems pretty crazy to me because I haven't really gone in depth in that. So I've used queries a lot. So I've basically worked on the client side for GraphQL, right? But not really on the backend side. So let's see if the documentation guides us on the backend side of it. But let's see. Okay. So before we start reading the documentation, I should tell you there are actually 3 operations that we can do in GraphQL. So in REST APIs we have HTTP verbs, right? Like get, post, put, delete, patch, and all. So basically each actually you can do anything with any HTTP verb, but the fact that they are there is that basically let's say you want to fetch a list of users, right? So there you'll use get. Let's say you want to create a new user, you'll use post for that. For updating we have put and patch. I think I can create a short video on put and patch. Anyways, so we have put and patch on that. And then what did I say? Delete, right? To delete a resource basically. Here all the requests are by convention sent on a post request, right? And and there are 3 operations in GraphQL. So first one is queries, second one is mutation, and the third one is subscription, which I haven't ever used yet, but I believe that is to achieve real-time response or something like that. Okay, so basically the idea should be that you go and subscribe to a stream or something, right? And whenever that stream is updated, you will get the real-time response in that, right? About query and mutation, those are the most common operations that are used in GraphQL. So queries, as you might think of, is like querying, right? I don't know how to explain this. Okay, so let's say the example of listing a users, fetching a list of users, right? So there we can use queries. Queries basically return us a response, right? So it is like a get response, but again we are sending it over a post by convention. Okay. And mutation is used for creating, updating, deleting anything where you are changing the value, like updating or deleting or creating, and I'm repeating myself, you use mutation in that. Okay. So let's see introduction to GraphQL. Okay, GraphQL is a query language for your API and a server-side runtime for executing queries using a type system. Yeah, exactly. GraphQL has an amazing type system, right, which we will see later on. Okay, GraphQL is a query language for API. Type system you define for your data. GraphQL isn't tied to any specific database or storage engine and is instead backed by your existing code and data. A GraphQL service is created by defining types and fields on those types, then providing functions for each field on each type. For example, GraphQL service that tells you who the logged in user is, as well as the user's name might look like this. So there's a type of query, and then there's this type user, which will have ID and name. So here we are, the query is returning or has property me, which has type user, and the user type has ID and name, and ID is an ID. I believe GraphQL has an ID type, like we have integer, string and all, and ID is a built-in type to GraphQL. I think they would tell us that. And then we have name of type string. Okay, along with the functions for each field on each type. So we have function query me, request or dot user, and function username, user dot get name. I'm assuming these methods exist on the user field. I'm guessing that, but let's see. Let's keep reading and let's see. After GraphQL service is running, typically at a URL on the web service, it can receive GraphQL queries to validate and execute. The service first checks a query to ensure it only refers to the type and fields defined, and then runs the provided function to produce a result. Okay. For example, the query could produce the JSON result like this. To learn more, continue reading. Oh, that was short. I gave a better introduction than that. Anyways, let's keep reading. Okay, so the one thing I love about GraphQL documentation is that you can write here inside this, you can write the things and it will fetch the data then and there. So you can, in real time see what is happening. Let's say I'm not really sure what is the field, but let's see ID. Okay, so it also fetched ID. Now let's try friends. I'm guessing it will be okay, so yeah, as you can see, we fetched hero, then we fetched name, R2D2 and ID. So okay, we can remove that, and then we fetched the name of that hero. And you might think this is not very impressive right now, or you do, but if you don't, just in case you don't think that this is impressive, think of what is happening here. I didn't have to use a different API, right? I just added two fields here, and I was returned with the whole collection of a nested response. And that is pretty crazy. If you have used REST API, you know how difficult it is. I mean, it's not very difficult, but it is cumbersome to, add nested response to an API, or you have to create another API as a whole. So This is quite impressive. Now, let's keep reading it and let's see what happens. So, at its simplest, GraphQL is about asking specific fields on an object. Let's start by looking at very simple query. So, we saw that. Now, you can immediately see that query has exactly the same type and same shape as result. This is essential to GraphQL because you always get back what you expect, and the server knows exactly what fields the client is asking for, right? The field name returns a string type, in this case the name of main hero of Star Wars, R2D2. Oh, one more thing, the query is above is interactive, which I already told. So if I add appeared in and add a comma, and we see all the movies that this hero has appeared in. By the way, I have not watched Star Wars, so I can't confirm it, but I know this should be good, right? Okay. In the previous example, we just asked for the name of our hero, which returned a string, but fields can also refer to objects. In that case, we can make a subselection of fields for that object. GraphQL queries can traverse related objects and their field, letting clients fetch a lot of related data in one request instead of making several round trips as one would need in classic. Oh, damn. I just told you that. Okay. So the same thing which I told a few minutes back or 1 minute back. So GraphQL can traverse related objects, and in REST API, we would generally be writing multiple requests. GraphQL can do that in a single request only. Note that in this example, the friends field returns an array of items. GraphQL queries look the same for both single items and the list of items. However, we know which one to expect based on what is indicated in the schema. By the way, schema is also an important concept in GraphQL. So basically, schema is a JSON file which will basically define all your types and all the things that are related, right? And that actually makes it very, very efficient for developers and as well as for the GraphQL engine to handle a request, right? So schema will basically define everything that is related, all the types and every field in every object. That's what a schema is. Okay. Arguments. So if only things we could do was traverse object and field, GraphQL would already be very useful for data fetching. Agreed. But when you add ability to pass arguments to fields, things get much more interesting. Okay, so was that a human or a hero? Okay, hero. Okay, so here we are passing an argument to human. Let's try 101 Darth Vader. Okay, I guess he's a villain. Luke Skywalker. Okay, so basically we can change the ID as well here. So again, compare it with the REST architecture. What would you do? You would create another API endpoint which will have an ID placeholder, right? Where you can pass. And look at this. I hope it should work like that. Oh no, we would need an ID. Okay, my bad. I was gonna tell you something different, but let's wait for that. Anyways, in a system like REST, you can only pass a single argument, in a single set of arguments, the query parameter and URL segments in your request. But in GraphQL, every field and nested object can get its own argument. That is great. Okay, by default, I think it was meter. Yeah, 1.72. Wait, 1.8. Yeah, so it was meter, then we converted to foot. So basically it need not to have a single variable only, single argument only. You can have nested, your nested object can have n numbers of arguments. I'm guessing that, or there is some limit to the nesting, but I'm not sure. Let's keep reading and find out. Arguments can be of many different types. In the above example, we have used an enumeration type which represents one of the finite set of options. In this case, unit of length, either meter or foot. GraphQL comes with default set of types, but GraphQL server can also declare its own custom types as long as they can be serialized into your transport format. So basically we can define our own types, right? But yeah, we need to serialize that on our own. So that's one thing that you need to keep in mind when you're defining your own type. Anyways, so if you have sharp-i, you may have noticed that since the result object match the name of field in the query but don't include argument, you can't directly query for the same field with different arguments. That's why you need aliases. They let you rename the result of the field you want. Okay, I did not notice that. Okay, so basically in the result you can also rename the fields that are coming, and I don't think you can do that in any way in REST unless you change the API architecture, right? Or API directly. So that's pretty impressive. So here we were getting hero episode this. So if we didn't do this, I guess we should get hero. Yeah, hero. And since we did that, we are renaming this, right? So that's pretty cool. I'm not really sure. Yeah. So in the above example, the two hero fields would have conflicted, but since we can alias them to different names, we can get both in one result, right? So wait, if we try to do this, there's a conflict, right? So we are basically requesting for two heroes, so the data would have hero field and then hero field, right? So that's restricted because in each hash map or dictionary or JSON file, one key, there will be unique keys, right? The value can be repeating, but the keys should be unique, right? Okay. In the above example, yeah, conflicted types. Okay, we got that. Then we have fragments, and I guess this is pretty cool because we can create a fragment and then you can use it in multiple places, right? So let's suppose you have a really big what do you say, really big request format which will be repeated at times, right? And you know that, so you can create a fragment and then just spread them in your request. Okay, let's say we have a relatively complicated page in our app which lets us look at two heroes side by side along with their friends. Imagine you can imagine that such a query could quickly get complicated because we would need to repeat the fields at least once, one for each side of comparison. That's why GraphQL includes reusable units called fragments. Fragments let you construct sets of field, then include them in queries where you need to. Here's an example of how you can do that. Okay, so we already saw this. So we create fragments, fragment name on, and I'm guessing this is an object type, right? Character, and then we are basically writing all the things that we need, and then let's try hero for a second. Okay, we have human. Will it change? Okay, right, comparison changed, or I'm not sure if it wasn't there. Yeah, it was there. and it changed. So apparently, okay, R2D2 is not a human, I guess. It's a robot or something like that. I promise you I haven't watched, but I know some bits by watching the Big Bang Theory and all, right? Anyways, you can see how above query would be pretty repetitive if the fields were repeated. The concept of fragments is frequently used to split complicated application data requirements into smaller chunks, especially when you need to combine lots of UI components with different fragments into one initial data fetch. Using variables inside fragments, it is possible for fragments to access state variables declared in query or mutation. See variables. Okay, we have that later on, I guess. It's a hash. That's why. Okay, we'll see that. Anyways, using fragments inside variables, using variables inside fragments. So we have okay, we have dollar first. Okay, I got this. So basically we are making fragments now dynamic, right? So while hero comparison, we are passing first int equals 3, and then first friend connection, we are basically passing down the variable here, right? And let's try and change. Obviously it will work, but okay, let's change it back. Anyways, we'll see variables later on and see in depth why and how that are being used, right? Let me just quickly variables is there. Oh, next only, right? So let's see, operation name. Okay, so up until now we have been using shorthand syntax where we omit both the query keyword and the query name, but in production apps it's useful to use these to make our code less ambiguous. Here's an example that includes the keyword query as operation type and hero name and friend as operation name. Okay, so basically we can name like query this or mutation this, something like that, I guess, to just tell. Okay, operation type, yeah. So I told you that there are 4 types of operation. My bad. Wait, no, there are 3 types of okay, my bad. There are only 3 types of operation that I told you before. Okay, the operation type is either query, mutation, or subscription and describes what type of operation you are intended to do. The operation type is required unless you are using query shorthand syntax, in which case you can't apply a name or variable definition to your operation. So basically you ought to define operation type and then operation name, right? Operation name is meaningful and explicit name for your operation. It is only required in multi-operation documents, but its use is encouraged because it is very helpful for debugging and server-side logging. When sometimes something goes wrong, you see error either in your network logs or in the logs of your GraphQL server. It is easier to identify a query code base by the name instead of trying to decipher the content. Think of it like a function name in your favorite programming language. For example, in JavaScript, we can easily work only with anonymous function, but when we give a function a name, it's easier to track it down, debug our code, log when it's called. In the same way, GraphQL query and mutation names, along with fragment names, can be useful debugging tools on the server side to identify different. So basically, bottom line, use operation type and name. That's it. Okay, now we have variables. Okay. So far we have been writing all our arguments inside the query string, but in most applications the argument to fields will be dynamic. For example, there might be a drop down that lets you select which Star Wars episode you are interested in, or a search field, or a set of filters. It would be a good idea to pass these dynamic arguments directly in the query string, because then our client side code would need to dynamically manipulate the query string at runtime and serialize it into GraphQL specific format. Instead, GraphQL has a first class way to factor dynamic values out of the queries and pass them in separate dictionaries. These values are called variables. So basically, make your queries dynamic using variables, right? And we all know what variables are, right? So yeah, when we start working with variables, we need to... Is my voice audible? Am I audible? Anyways, when we start working with variables, we need to do three things. Replace the static values in the query with variable name, declare variable name, notice this $sign before variable name, as one of the variable, declare variable name as one of the variable accepted by query, pass variable name value in separate transport specific, usually JSON variable dictionary. Okay, so what we are doing here, here's what it's look like. Okay, so first replace static value in query with variable name. Okay, so we have to replace. So for example, here we would type, my bad, Jedi, right? The variable is never used. Okay, so I'll just cut this for the moment and remove this, and that's enum, so I can simply use this. Okay, so yeah, okay, so that's the same thing. Instead, what we were doing, now I had to write everything. Oh, come on, man. Episode, and there we have it. Okay, so what we have done is replaced all the static values with variables, right? Variable name. Then we have declared variable as one of the accepted by query, right? So like this, I guess. Then pass in a separate transport specific, usually JSON variables dictionary. So we have this variable dictionary, separate variable dictionary in JSON format, where we are telling that what variable will be accepted by the query, or basically a variable value, right? Okay, works. Now in our client code, we can simply pass a different variable rather than needing to construct an entirely new query. This is also in general a good practice for denoting which argument in our query are accepted to be dynamic. We should never be doing strings interpolation to construct query from a user specific values. Okay. Variable definitions. The variable definitions are the part look like this. Okay, so here we had episode : episode. So basically variable name : then variable type, right? The type of object in the query above. It works just like argument definition for a function in typed language. It lists all the variables prefixed by $ followed by their type. In this case, episode. Just give me a minute. Just give me a minute. Okay, that looks better. Actually, my the video is lagging. The stream is lagging. I'm not sure if it's for everyone or my voice is not that much lagging, or I'm not sure what is happening because I can't hear my voice. But let's keep doing what we are doing. Okay. All declared variable must be either scalar, enum, or input object types. So if you want to pass a complex object into a field, you need to know what input type that matches on the server. Learn more about input object types on schema page. I guess we would have schema and types page. Yeah, and I'm not sure if we will be doing that today. Anyways, let's keep on going. Where were we? Yeah. Variable definition can be optional or required in the case above. Since there isn't an bang next to episode type, it's optional. But if the field you're passing the variable into requires a non-null argument, then variable has to be required as well. So basically, when we pass exclamation mark, the variable are required, right? In TypeScript, I guess we have the opposite thing. So by default, everything is required, and if we have some object property that we need to be optional, we basically add question mark. So yeah, that's one difference that I can see the type system has from TypeScript and GraphQL. Okay. To learn more about syntax for these variables, variable definitions, it's useful to learn the GraphQL schema language. The schema language is explained in detail on the schema page, which we will see in the next video. Hopefully. All right, so this is going pretty good. I had tried streaming before, but I was getting the bitrate basically was dropping a lot, and so far we are live for 31 minutes, almost 32 minutes, and I haven't seen this thing go red. So basically there's an indicator which will go red if the bitrate is really low. So that's quite impressive, yeah. Okay. Default variables can also be assigned to the variables in the query by adding default value after type declaration. Query this. Okay, so basically we put equal and define the default type, right? Same way in JavaScript language or TypeScript. When default values are provided for all variables, you can call query without passing any variables. If any variable are passed as the part of variable dictionary, they override the defaults. So basically, if you pass variable, they will override the default ones, and same way we use in JavaScript if you have used JavaScript basically. Directives. We discussed above how variables enable us to avoid doing manual string interpolation to construct dynamic queries. Passing variables in arguments solve a pretty big class of these problems, but we might also need a way to dynamically change the structure and the shape of our queries using variables. For example, we can imagine UI component that has a summarized and detailed view where one includes more fields than the other. What did I just read? I just blanked out for a second. My bad. Okay, so we discussed above variables enable us to avoid manual string interpolation and to construct dynamic queries. Passing variables in arguments solves a pretty big class of these problems, but we might also need a way to dynamically change the structure. Oh, structure. My bad. Structure, right. So there are directives which will help us to change the structure of queries. For example, here we have a variable, right? And we have at include directive, right? Which is taking if with friends. So basically, if would take a true or false value, like in any place in programming. If there is if, it will accept true or false value, right? Okay. So here also, if will take a true or false value, and include will basically, I'm guessing it will include this thing if this is true. So let's try. My bad. True, and it will include. Amazing. Okay, try editing variable. Okay, we saw that. Okay, there's another directive skip. So include only if this field is if the field in the result. What am I doing? Anyways, only include this field in the result if argument is true, else skip if boolean. Skip this field, right? So skip would be totally opposite. So basically, include if true and skip if true. So that's I guess self-explanatory, right? Directives can be useful to get out of a situation where you otherwise would need to do string manipulation to add or remove fields in your queries. Server implementation may also add experimental features by defining completely new directives. So we can also define our own directives in our server, which we'll see in the next video. So subscribe, please. Anyways, okay, now we are in mutation. So we have covered all the basic topics of querying GraphQL server. Now we come to mutation. As I told you before, mutation is used for anything that will change something in your database or in your data or whatever, wherever you are wherever you are, what do you say, where else do we store data? Files, yeah. Okay, so wherever you are storing data, basically, right? Most discussions of GraphQL focus on data fetching, but any complete data platform needs a way to modify server-side data, right? So basically, to modify the data, we use mutations. In REST, any request might end up causing some side effects on the server, but by convention, it's suggested that one doesn't use GET request to modify data. GraphQL is similar. Technically, any query could be implemented to cause a data write. However, it's useful to establish a connection that any operations that cause writes should be sent explicitly via mutation. Just like in queries, if the mutation field returns an object type, you can ask for nested fields. In this can be useful for fetching new state for an object after update. Let's look at simple example mutation. So let me ask you a question here. If you have used React or any JavaScript library framework, which basically helps you manage state, right? How do you exactly manage state after you call mutation? So here is mutation something. Let's call it delete, right? If you're deleting something from a list on the UI state, how do you manage in React? Comment down below, and should I tell you the answer? Okay, so basically what I do, I basically send a request, and once it is successful, and depending on it is sending me data or not, I can I will just filter that result from my state. So if that was successful, I need not wait for the data or traverse the data. I can simply filter that list of whatever that resource was, right? And since I have filtered it and updated the state, next time I reload, I should get the same state because that is fetching the data, I guess, in your data management use effect or whatever you're using, right? I'm not sure if that was clear. If not, comment down below. Anyways, so mutation, right? What we're doing, mutation, operation type, then operation name, right? We are passing EP and review. Okay, both are important fields since we are using exclamation mark. At this point, I guess we should start connecting the dots that we covered previously, right? So create a review. So we have a function, I'm guessing, create review or resolver, if you know what that is. Basically, there would be some implementation of this on the server side that will accept these two and basically update the things, right? So consider this is a post request, right? And this is the route which you're calling, okay? And this is the body of that post request, right? And then you are deciding, not the server, you are deciding what you will get in return, right? So I can also let's say, is there anything else? I don't think there is anything else. Anyways, so you are deciding what you will get, like in query, right? So that's pretty great. So you can directly update your state from here, right? I'm not saying that you can't do that in REST. You can, absolutely you can. I'm just saying this is much more convenient. Okay. Now, how create review field returns the stars and commentary fields of newly created review. This is especially useful when mutating existing data. For example, when incrementing a field, since we can mutate and query the new value of the field with one request. So basically we are mutating and querying the updated thing in one request. So that's pretty great. You might also notice that in this example, the review variable we passed it is not scalar, right? This was not scalar, correct? It's an input object type, a special kind of object that can be passed in as an argument. Learn more about. So basically there is something called input type object, which may not be scalar, which will not be scalar. And it is a special type of object, which we will learn in next video. So do subscribe. Okay, let's see. Multiple fields in mutation. A mutation can contain multiple fields just like a query. There's one important distinction between queries and mutation other than names. While query fields are executed in parallel, mutation fields run in series one after another. This means that if we send two increment credit mutation in one request, the first is guaranteed to finish before the second begins, ensuring that we don't end up with a race condition with ourselves. This is a very, very important and actually a major concern in computer science, the race condition. Basically what this is saying, that mutation operations ensure that one request will start executing after the previous one has finished running, right? Even if there are same mutation in the single request. In contrast, query fields can run in parallel. So that's pretty good, right? Okay, so I guess this is the last last one. Okay, so what this is, like many other type systems, GraphQL schema also include the ability to define interfaces and union types. Learn more everything in schema. Okay, so next video is going to be a big one, so don't miss out, and do subscribe. Okay, I promise I won't do that. If you are querying a field that returns an interface or a union type, you will use inline fragments to access data on the underlying concrete type. It's easiest to see with an example. Okay, let's see. I'm not really sure what happened here. So what we are doing, there's this inline fragments, right? So if we are querying a field that returns an interface or union type, you will need to use inline fragment to access the data on the underlying concrete type. So if there's primary function, okay, let's try and change the episode. I guess we had a list of episodes Empire. Luke Skywalker, that seems like a human. So right now we are not getting this, right? Let's try and change. Okay, so we got height. So why can't we do this exactly? So basically this is what it's saying, that if we are returned with an interface or union type, then we need to use inline fragments, right? So I'm not really sure how we are using. So basically what we are doing, if the hero, right, is droid, then we are getting primary function. So I'm guessing that hero returns a interface for prime, like if it's a droid, it will have something, and if it's a human type, the hero, it will have another fields, right, list of fields. So then we can use inline statement to access the data on the underlying concrete type, right? So I'm guessing that. Let's try and figure out what is happening. In this query, the hero field returns the type character. Okay, which might be either human or... Okay, got it. So what I said before, right? So basically, hero type will return character type, which can be either a human or a droid, which I just read, depending on the episode argument. So yeah, so if we have to do that, because first fragment, so to ask the field concrete type, so we can use inline. What is this? Dot 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 on droid. So basically spread on droid. You can I usually consider dot 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 as spread operator. So what we are doing basically is spread on droid. अगर droid है तो primary function, and if it is human, then height, right? Okay. Okay. Named fragments can also be used in the same way, since a named fragment also has type attached. Okay, so named fragments, I guess we used above. Yeah, this one. Okay, so basically we are replacing this, right? Anyways, the last topic, meta fields. Given that there are some situation where you don't know what type you will get back from GraphQL service, you need some way to determine how to handle that data on the client. GraphQL allows you to request underscore type name, a meta field, at any point in the query, and so yeah, so basically we are searching for this text, right? There should be some implementation of that, right? Anyways, so there is type name, and type name is human, so we are just splitting that, right? If it is human, then split name, where here we can simply do that. I don't know why this... Okay, in search it wouldn't be there, so that's why I'm not able to do that. Anyways, but it should be returning a character or something that it belongs to. Anyways, it returns a union type that can be one of three options. Okay, it returns a union type, right? Human, droid, or starship. It would be impossible to tell apart the different types from the client without type name field. Okay, so basically we can handle queries using type name. All right, next we have schema and types, which we would see in the next one, and validation in the next one. So I hope you liked this one. I'll be uploading this on YouTube, so you would mostly be seeing this on YouTube. And let me tell you, I don't want to tell you. Anyways, so I don't know how to end this. You can simply end it, like move on to next video or something like that. Anyways, it was nice, and I hope to continue doing this, right? And I will see you in the next one, where we talk about schema and types, and hopefully more GraphQL backend, which I need some brushing upon because I have to work on it. Anyways, I'll see you in the next one.